Welcome to this video. In this video, I'll be talking about transformations with logarithmic functions. Okay, so we'll be talking about transformations. In the previous videos, we already talked about transformations with exponential functions. And in previous chapters, we already came across different types of transformations, including translation, reflection, stretch, and compression. Right, so now we're going to apply all of those transformations on the log function. Okay, so here what you see right now, I have f of x is equal to log x to the base of 2. In all these videos, you see that I like to use this log x to the base of 2 as an example because having the base of 2, it's easier for us to get the points, the coordinates. Okay, so it is not always true that your base must be a 2. Right, I'm just using that as an example for you guys. Okay, now, if f of x is equal to log x to the base of 2, then it should have this vertical asymptote, here. Okay, and we already talked about that in the previous video. Now let's get a few points. So I would have one at so the few points. If I move around this. If there's one x-intercept here, then that is going to be 1, 0, right? That's 1, 0, 1, 0. Okay, let's see what other points we have. Maybe there's another one here. This will be 2, 1. Right, that's 2, 1 right there. So there's another point there, 2, 1. Okay, so these are the points that I have on my log x to the base of 2. I should have another one here. We can go with, if you guys want another point, there's another one here, 4, 2, right, 4, 2. But I think having 1, 0 and 2, 1, oh, you know what, I'll just get another one. So this is 4, 2. So I have 4, 2. Okay. Now, I'm going to carry out some transformations and we will see how does it affect the points that we have here. Okay, so here my g of x is the blue one, so let me make that different color. Okay, so what I'm going to do is I'm going to start out with the translation first. Okay, so if I add a 3, so add 3 to my x. If I add a 3 to my x, when I show this g of x, it should be on the left-hand side, of this red graph that I have right now, which means this 1, 0 is gonna be at it's gonna be on 3 units to the left, so that's gonna be -2, 0, and then this 2, 1 will be at 2 minus 3. That's gonna give us -1, 0. Okay, and I'm gonna have another point. The 4, 2 will be at 1, 2. Oh, this is not 0. Sorry, that should be 1. Okay, so if I show the graph. There you go. So my g of x is now 3 units on the left of my original f of x. Okay. So by adding this 3, I move the entire graph to the left-hand side by 3 units. How does that change our vertical asymptote? Right now, you see this vertical asymptote, that is for my f of x. But if I have moved my entire graph to the left by 3 units, then my horizontal asymptote would also be moved to the left by 3 units. So now my horizontal asymptote is going to be there. You see that? Originally it was here. It was the y-axis. But now because I have moved my entire graph to the left, so my horizontal asymptote would be also shift to the left by 3 units as well. Okay. Same thing applies when if I move this to the right, then that becomes minus. Okay, so let me hide these points. If I move everything to the right, you can see that the 1 0 is now 4 0, and my horizontal asymptote must also be moved 3 to the right. Okay, so now there's my my vertical asymptote. Sorry, my bad. My vertical asymptote is also moved 3 to the right. So that's horizontal translation. Now let's look at, and let me bring the vertical asymptote back. Okay, now I'm gonna make some changes to my equation. I'm gonna talk about vertical translation, which means I'm going to add a value, not just to the x. I'm going to add value to the whole entire function. So let's say plus 3. So now this is going to go up by 3, right? It should go up by 3, and let's see if that's true. So this 1 0, if it moves up by 3, then I should have, let me see if I can just get the point there. Now that point is now 1 3. Okay, 1 3. The y went up by 3, right? The y went up by 3. This point 2 1, if it goes up by 3, it's going to be at 2 4, and you can see that it's right there, 2 4. Okay, this point 4 2 is going to go up by 3, so that would be at 4 5. Okay, 4 5. All right. So if I move, if I'm having this at 3 plus 3 at the back to the entire function, I move the whole graph up by 3. What do you think? What impact does that have on the vertical asymptote? Just now when we did the horizontal asymptote, the horizontal asymptote also follows the transformations, right? Right now, if my vertical asymptote, sorry, I keep on saying horizontal. In this case, we're only talking about vertical. Yeah. So if the vertical asymptote is also going to follow the transformation, in this case going up 3, then is the equation of my vertical asymptote going to be changed? If you have this vertical line that extends forever, right, and if you move it up and down, it's not going to make a difference, right? So when we have vertical translations of your log function, your vertical asymptote stays the same. It is only when we have horizontal translations, that's when your vertical asymptote will be affected. Okay. Now, if I switch this to minus 3, then we should see that it went down by 3. Right. So this is 1 and negative 3. This is 2 and negative 2. This will be 4 and negative 1. Okay. So that's it. That's it for translation. Now let's look at reflection. Let's do horizontal reflection first. So if it's horizontal reflection, I need to multiply a negative to my x. So I have a negative here, and there you go. I have my horizontal reflection across my y-axis. So the point 1 0 becomes negative 1 0. This point 2 1 is now negative 2 1. Negative 2 1. And 4 2 is now at negative 4 2. The y coordinates stayed the same, but the x coordinates, the signs are changed. Is there any change on my vertical asymptote? No, right? The vertical asymptote stays the same. However, my domain does change a little bit, right? My domain is no longer the same. So my domain would, in this case, for my green curve, my g of x, it will be from negative infinity all the way up to 0, not including 0. Okay, so the domain has not changed. The domain has changed as well. okay, just by flipping the sign. Alright, so this is my horizontal reflection. Now let's look at vertical reflection. If I have a vertical reflection, I'm going to multiply the original function by a negative in the front. So you can see that I have vertical reflection across the x-axis. So which means all of my y coordinates will the signs of my y coordinates will be changed. This point y is 1 0, since my y coordinate is a 0, so that's not going to be affected. But this point 2 1, that will be affected, right? Because the y coordinate is a 1, so now that point is now going to be at -2, -1. Okay, 2 -1. This point 4 2, it's going to be changed to 4 and -2. Okay, 4 and -2. Alright, so this is vertical reflection. Again, did our asymptote change? No, right? The vertical asymptote stays the same. Okay. Alright, so we talked about translation, we talked about reflection. Now let's look at compression and stretch. I'm going to start with horizontal compression and stretch first. So let's say if I multiply this by 2, if I multiply the x by 2, this will be a horizontal compression. This will be a horizontal compression, and we learned that we learned before that these 3 points that I have right now, the x coordinates will be changed. Instead of multiplying the x coordinates by 2, I'm actually going to do the opposite, divide them by 2. So I'm going to have, so this 1 0, that would be 1 over 2 0. 2 1, that will be at, divide 2 to, if it right now the x coordinate is 2, divide that by 2, I get 1, right? And then for 4 2, that will be at 2 2. And let's see if our prediction is correct. And you can see that it is. Our prediction is correct. It is indeed correct. Okay. Alright, so for now, if you're comfortable with carrying out the transformations, none of this should be new. We're just applying the same skills on exponential graphs. So this is horizontal compression. If I want to make it horizontal stretch, I will have to multiply that by, say, 1 over 2. And then you can see that my graphs are now different. It's a horizontal stretch. So you can see that the green color curve is my g of x. So my y coordinate, again, this is horizontal, so my y coordinates are going to stay the same. So my 1 0, I'm going, instead of multiplying by half, I'm going to divide by half or multiply by 2. The x coordinate 1 is going to be multiplied by 2. I get that. This point 2 1, that would now become 4 1. I'm going to multiply the x by 2, so I have a 4 1 here. Okay, 4 1. This point 4 2 now is going to be at 8 2. Okay, 8 2. Right. So that's it. That is on horizontal compression and horizontal stretch. Last one, vertical stretch, vertical compression. So if I have a 2 in the front, then I'm gonna have a vertical stretch. So in other words, my graph is gonna become taller. So you can see that my 2 1, this case, is now at, my x is still gonna stay the same, but my y will be multiplied by 2. So now the point 2 1 is now 2 2. This point 4 2, it is gonna, my x coordinate will stay the same. So my y coordinate will multiply by 2. So I'll be at 4 4. 4 4. Okay. Okay, so that's vertical stretch, and vertical compression would be, let's say, 1/2. So now the graph is become shorter. But 2, 1 is now at the point 2, 1 now will be at 2 and 0.5. So the y coordinate is multiplied by half. This point 4, 2 is now gonna be at 4 and 1. 4, 1. The point 1, 0, since the y coordinate is 0, it does not get affected. Alright. This video is a bit long, but I hope you guys understand how did I change the coordinates of the points according to the transformations. And please make sure you pay attention to the vertical asymptote. For now, it seems like it is only the horizontal transformations, especially the horizontal translations. That's when we will change the vertical asymptote. You need to be very aware of the effect of your transformation on the asymptote. Hope you guys find this video helpful. I'll see you in the next video. Bye bye.